We are going to use the example on the screen. So for the first method is using the transfer function which is TF. It has two arguments. The first argument is the coefficients of the numerator equation. So for the numerator we have x plus 1. So the coefficients are 1 and 1. That is, the coefficient of x is 1 and the cosine is 1. And for the denominator we have the coefficients as 1, 8, 19 and 12. So this will give us our transfer function model. So for the second method, again, we make use of the transfer function, but here we have to first of all define our complex variable s. So s is transfer function, and the argument while defining x is just the character x, and we have our x complex variable. So you can use it to then define our transfer function. We have x plus 1 then divided by s to power 3 plus 8 times x to power 2 plus 19 times s and then plus 12. So that will give us our transfer function model. And the final method is also, first of all, you have to define the complex variable using the ZPK function, which stands for zero fold gain. So you just have to put ZPK, and you, for the complex variable x, it is just an x. That means it is just a 0 at 0. It doesn't have any fold, and the gain is 1. So for z, the first for the 0, as you can see 0 here, so it means it has a 0 at 0. It doesn't have any fold, so you just put an empty vector, and for the gain is 1. So you have your x complex variable, so you use it again. So g3 will be x plus 1 again, and then divided by s cubed plus 8 times x squared plus 19 times x and then plus 12. So this is our transfer function model. So for the zero fold gain model, actually it factorizes the transfer function so that you can clearly see the location of your poles and zeros as well as the gain of the model. Thank you for watching.